Okie dokie. Hey guys, how you doing? Welcome back. Hope you guys had a wonderful half-term holiday. I certainly did. Relaxed. Had some, good time out with, friends and in a social distancing manner. And yeah, it's great to have you guys back. Today we are going to be getting back to work today. We're going to be going through topics in A level, and that topic is trigonometric identity. So we're going to start off with AS level. However, hopefully you will find some of the concepts we're going to learn today quite useful for A level, as AS level is a prerequisite for A level. So as ever, if you guys have any questions, feel free to ask. Feel free to participate. We're here to help you guys out. So ask as many questions as you can and want. We should have Stuart, the guy who created ExamSolutions, on the chat. So if you guys have any issues, just feel free to ask, and I'm sure in his able hands he'll be able to help you guys out. Anyways, without further ado, let's get straight into doing some A levels, guys. All right. Okay, so today we're going to be using trigonometric identities that most of us would have seen at AS level. Okay, sine squared x plus cos squared x is equivalent to 1 is one of the identities that is, derived from a Pythagorean identity, which you actually get from the unit circle. So it's one of the famous ones, if you like. This one also can be derived using SOHCAHTOA. Tan x is equivalent to sine of x over cos of x. Notice that we've got these three lines here, and we'll talk about what the significance of equivalence a bit later, but it just means equivalent. Okay, it's not equal to, it's equivalent. Okay, these two here we have are what's called the double angle formulas. Okay, now for some of us that are doing A levels, you should be able to derive the first, these using the compound angle formula. Okay, so we're just basically going to be using these identities to solve some problems now. And let's see how you guys get on, okay? All right, so first off, simplify the following expressions. As quickly as you can, guys. I want to see who's going to get this first. Just using the identities we've just spoken about. Bear in mind that these are actually not in your exam, okay? These are not given in your exam. So you'd either be required to memorize or be able to derive it. Who's got it? Who's first off? By the way, there's a bit of a lag, so Natalie first in with 1. Okay, sine squared of 3 alpha plus cos squared of 3 alpha. Anyone else? Anybody else? Natalie's the only person that believes the simplified expression is 1. Jinga, Ella, 1 as well. Anyone else? Anyone else? 1. Okay, cool. I'm going to take that as being correct. Okay. Now, the whole idea is that comparing with this identity here, it doesn't matter what is inside your argument. Okay. Whatever the angle is, that's why this is given the term x. It really doesn't matter what's inside. Okay. As long as it satisfies this identity, it's going to be equal to 1. Okay. Very, very good. Okay. All right. The next one up. Let's go. Question 2. Simplify the expression 7 minus 7 cos squared x. Who's got this? David says, is there a good resource for that? Could that be deriving the formulas, or what exactly is your question, Dave? Okay, who's got this? There is a little bit of a lag, as I say, so it does take a few more seconds to feed into me. 7 sine squared x. Cool. Okay, we've got 1 in from Ella. Anyone else? 7 sine, I believe you mean also squared x. Emma? Emma, welcome. Haven't seen you on before, but very welcome and thank you for participating. Mohammed, 7 sine x squared as well. Okay, it seems to be getting a general consensus here. The answer is indeed, okay, so before we actually get to the answer, in order to simplify this expression, we need to factorize by taking the highest common factor of both terms. That's 7, okay? So that gives us 7 times by 1 minus cos squared x. Well, using the equation 1, simply subtracting sine x, simply subtracting sine squared x from both sides, we get 1 minus cos squared x. Actually, sine squared x is equivalent to 1 minus cos squared x, giving us an answer of sine squared x. Okay, good stuff. All right, well done for participating, guys. Let's have a go at this question here. Simplify the expression tan x times by cos x. Let's see who's going to crack this one. So Natalie comes in with sin x straight away. Mohammed, sin x, Din, sin x. Do we need to know the formulas in the corner? Good question. You do need to know these formulas. They are not given in most of the exams, I believe. So you'll either be required to memorize or derive them. I can teach you how to derive them in a separate tutorial. Most of you guys coming in with sin x. Let's see what the answer is. Okay, so looking at this expression here, we know that tan x using equation 2 is equivalent to sin x divided by cos x. Okay, so just rewriting that as sin x divided by cos x, we can hopefully then see that there's some nice cancelling between the numerator and the denominator. So our cos x is cancelled, giving us that this term is equivalent to sin x. So very, very well done, guys. Good stuff. Good stuff. Looks like we're all on 100% so far. Let's see if we can keep the momentum going. All right. Let's have a go at this question. Question 4. Cos of theta plus sine of theta tan theta. How do we simplify this expression? Who's got this? Anyone know? Right. First two form. The others are in A level. Okay. And who's got this? Who's going to be the first one on this? We've seen a couple of the usuals regularly participating, the Natalies, the Dins, Mohammed, Ella, good stuff, Jasmine as well, Isabel, Jinga, Marcus, thank you very much. Let's see who's got this. All right. Whoa, okay, so Pooh comes in with, is it okay for me to call you Pooh, by the way? Cos of alpha plus sine alpha. I'm not quite sure what that is there. You've got. So we've got Din with 1 over cos theta. Anyone agree? 1 over 2 tan theta coming in from Ella. Marcus coming in with 1. Mohammed coming in with sec theta. He sounds like an A-level guy. Okay, cool stuff. Pooh, mistyped. All good. All right. Okay, let's go through the question. All right. So once again, tan of theta can be rewritten as using equation 2, sine of theta over cos of theta. Okay. Now we can evaluate this expression here, sine theta times by sine theta, to give us sine squared theta. Okay. Now that's going to give us an equivalence of cos theta plus sine squared theta divided by cos of theta. Okay. Now you guys need to be comfortable at this stage with performing operations with fractions, algebraic fractions and rational functions. Okay, I've included a couple of useful links down below for videos made by Stuart on these. You need to be very comfortable at this level. Okay, so in order to evaluate this sum here, we need to get a common denominator. So cos of theta is the same thing as cos of theta over 1, right? So if we multiply this by cos of theta and the denominator by cos of theta, we get cos squared theta plus sine squared theta divided by cos of theta. Okay, we get a common denominator. Okay, I've quickly just done that there. And using our equation 1, we can see again that big identity that we keep talking about keeps popping up, and it's equivalent to 1, and therefore our answer is equivalent to 1 over cos theta. So very well done. So I think Dim was first in on that, and Mohammed came in with sec theta. He is correct indeed. This is what's called the reciprocal of cos of theta, which is called sec theta. okay, which is an A-level thing, all right, which we'll go through in due course. Good stuff. Let's go for one last one before we move on. Let's have a go at this one. All right, so last one for simplifying expressions, we've got sine 2 theta divided by 1 minus sine squared 2 theta. Who's got it? Oh, you got it now? Good stuff, Jasmine. Make sure you make sure you let us know, if you don't understand it. We'll be more than happy to explain it to you. Who's got this? What will you do? There are various ways that you can write the numerator and denominator. So we've got tan 2 theta there. Okay, we've got tan 2 theta again. Tan 2 theta seems to be a general consensus. Ben, welcome. 27 stories, welcome. Tan 2 theta. Ella as well, tan 2 theta. Mohammed, good stuff, tan 2 theta. Okay, let's go through this one. All right, so let's have a look at this. So let's choose a denominator to work with first. The denominator can be rewritten using equation 1. Okay, remember, it doesn't matter what the argument is. Here it's 2 theta, and equation 1 is x. It really doesn't matter. It's just an arbitrary variable. Okay, so using equation 1, we can rewrite the denominator as the square root of cos squared 2 theta. Okay, now it's important for you to understand how we do write, another way to rewrite cos squared 2 theta. Okay, it's also the same as the square root of cos 2 theta all squared. Okay, and hopefully you should then see that the square root cancels a square. So in the denominator, we actually get cos of 2 theta. All right, so we've actually done nothing to the numerator here. And finally, using equation 2 here, we should be able to see that this is equivalent to tan 2 theta. So very, very well done, you guys. We're all smashing it once again. Good stuff. All right, we're going to move on now. We're going to move on to proving identities. Okay. Now, proving identities is one of those things, it's all, some see it as a science, some see it as an art. I must say that there is really no hard and fast rule. So long as you use the correct identities, which are given here, and you also use the correct operations, the only other thing I would just recommend is to have a plan or strategy. So proving a trig identity is in using this definition here. Well, the word I used for this before was equivalent, which means you can actually prove from left hand side to right hand side and vice versa. You can also prove that the right hand side is equivalent to the left hand side. Okay, but for the general purpose of today, most of the time we're going to be proving from the left to right. Okay, cool stuff. So as I say, have a plan. All right, so on the right hand side I see a cos squared theta term. All right, so how can I get cos squared theta? Well, I know that if I multiply out the left-hand side, I'm going to get a term. You should be able to see that we should get a sine squared theta term. And we know how sine squared theta and cos squared theta should be related using equation 1. All right, so how I'm actually going to multiply the left-hand side out is by using the difference of 2 squares. Okay, which simply tells you that the difference of 2 squares can be written as a product of conjugate pairs. Okay, we'll talk about conjugate pairs a bit further on. So it just provides a really, really quick way for you to multiply out brackets that are conjugate, okay, using this definition, if you like, from right to left in this case. Okay, so then you should hopefully see that this is equal to 1 minus sine squared theta using equation 1. And our answer is cos squared theta. By the way, guys, as I'm showing you guys, hey Alonso, how you doing? That's one of my guys. Good to see you on. You guys should be free to participate while I'm explaining, okay? And see if you can beat me, all right? See if you can beat me before I get the answer. Okay, so we've managed to prove that the left-hand side is equal to the right-hand side. Let's have a look at another one, okay? So here's one here. So we have cos to the power of 4 theta minus sine to the power of 4 theta over cos squared theta is equivalent to 1 minus tan squared theta. Okay, so as I said before, let's try and have some type of strategy. All right, so we need to show that the left-hand side is equivalent to the right-hand side. And I can see on the right hand side I've got tan squared theta. Well, from equation 2, you should be able to see that tan squared theta is equivalent to sine squared theta over cos squared theta. Okay, now we have cos squared theta in the denominator, don't we? The only thing that we need to do is find sine squared theta in the numerator somehow. Now, how we can do this is if we can find some way of reducing this term such that we get sine squared theta out, we can cancel the terms out and get tan squared theta. So my strategy is to find sine squared theta somehow. Okay. All right. So looking at the numerator now, in some disguised sense, this is actually a difference of two squares. Okay. Where in this case, cos to the power of 4 theta is equivalent to cos squared theta all squared, and sine to the power of 4 theta is equivalent to sine squared theta all squared. Okay, so we can use a difference of two squares to quite quickly rewrite the numerator as a product of conjugates. Okay, as you can see here. Now, what comes out of this is that we get cos squared theta plus sine squared theta, as we know is equal to 1, or equivalent to 1 rather. And now, at this point, we've got cos squared theta minus sine squared theta divided by cos squared theta. Now, I'm sure some of you might recognize that this is a double angle identity, which we could say is equal to cos 2x. However, remember what the plan was. The plan was to get sine squared it somehow. Okay, so let's not use cos 2x. Let's actively not use that, and let's actually split this up using this rule. So we've got a fraction here, a single fraction, which we can split up using this rule as a sum of two different fractions. Okay. So splitting up and evaluating the terms, I get cos squared theta divided by cos squared theta, which is equal to 1. And here we have exactly what we were looking for, sine squared theta over cos squared theta. Okay, giving us 1 minus tan squared theta is proven. So we're good to go. Well done. So that's how we do this. That's how we prove. I would always recommend you use the right identities. Secondly, you want to make sure that you know how to deal with operations, especially with algebraic fractions. It comes up quite a lot. Things like difference of two squares are things that come up quite a lot in exams. Okay. All right, so it's time for you guys to have a go. Now, I figured out that without you guys saying done, it'd be pretty impossible for me to know if you're proving it. So what I want you guys to do is prove from the left-hand side to the right-hand side, okay? And after you've proved it, I want you to find me the missing value, okay? So let's have a go at this one. So what we need to do is prove that sine to the power of 4x minus cos to the power of 4x is equivalent to 1 minus something times by cos squared x. Let's see who's got this. Who has got this? Let's see who's able to give me that missing value we're looking for. So remember, I have a plan. How do we get a cos squared x term on the right-hand side? Natalie says 2. Anyone else? Anybody else? Okay, seems like Natalie's the only one who's seeing it right now. Okay, I'm gonna step in here and show you the answer. Okay, so as I said, having that strategy of, okay, so we want to get cos, okay, 27 stories comes in with 2 as well. Yeah, all right, we're coming in now. Ella as well, Pooh as well, good stuff. All right, so we're looking to get a cos squared x somehow on the right-hand side. So we need to in some way reduce this term here, okay, to cos squared x. All right, so using difference of two squares, once again, we can rewrite the left-hand side as this term here, okay? Now, as we know, using our standard equation 1 that this part here is equivalent to 1. So therefore we have sine squared x minus cos squared x. Now notice that we don't have cos squared x on the right hand side. So we need to find a way of eliminating sine squared x, okay? And we can do that using equation 1, okay? So sine squared x, as we know, is equivalent to 1 minus cos squared x. So substituting that in and evaluating this expression, we get 1 minus 2 cos squared x, okay? So 2 was the value I was actually looking for. All right, very, very good. That was very, very good, guys. Keep it going, and if you have any questions, feel free to just bang the question. I'm sure or I will help you out. Okay. This one is quite slightly harder. Okay. Sticky one, as they say. How would we be able to prove that 1 minus tan squared x is equivalent to something over cos squared x? Slightly trickier, but don't be phased. Again, just think of, I have my identities, I know how to perform my operations, and I have a strategy. I need to find cos squared x in the denominator in some way. How do I do that? What on the left hand side can help me get cos? Wow, Ella, straight in. Natalie, wow. Always seems to be a battle between you two guys. Anyone else? Anyone else out there? Anybody? Anyone agree? Again, Ben Clay comes in with cos 2x. I can confirm to you that the answer is right. The answer I was looking for was cos 2x. That was the term I was looking for in the numerator. Fantastic. Okay, so how do you do this? All right, so first of all, we notice that we need a cos squared x term in our denominator, okay? And you should know already from what we discussed earlier that tan squared x is equivalent to sine squared x over cos squared x, okay? So we're kind of almost there, All right, now the next thing we need to observe is that we only have one term here, but currently we have two terms. So how do you change this sum of differences, if you like, or difference? How do you change this difference into one term? Well, we need a common denominator in order to combine these fractions. You can always look at whole numbers as fractions, okay? 1 over 1. How do we get a common denominator? Well, if we multiply the top and bottom by cos squared x, this is what we get. And we now have a common denominator. We can now combine the fractions to get one fraction, okay? So that's going to give us cos squared x minus sine squared x divided by cos squared x. And using the double angle formula, cos squared x minus sine squared x is equivalent to cos of 2x, okay? So our answer is cos of 2x over cos squared x. So I was looking for cos of 2x. All right, fantastic work, guys. It's really good. Really glad you guys are getting involved. Okay, now this one's a bit of a sticky one. All right, this one is, I'm just trying to give you guys all different types of scenarios that come up when you're proving identities. And I'd like you guys to have a go at this one. I'm just gonna go ahead and explain it for time purposes. But I'll give you guys a clue while you're working on this. Conjugates, okay? So we need to prove that the left-hand side is equal to right-hand side. Again, we can do it from the right-hand side to the left-hand side, okay? Now, in the numerator, we've got 1 minus sine x, okay? And there's not too much we can do with that 1 minus sine x. However, we know that we can do a lot more with 1 minus sine squared x, right? Using the one of the Pythagorean identities, the major ones, okay? So a way we can actually rewrite this term here is by multiplying by its conjugate, okay? And as I mentioned earlier, conjugate, right? The conjugate of a plus b is a minus b, and the conjugate of a minus b is a plus b. Okay, now you guys should all be familiar with conjugates at this level. If you guys remember rationalizing surds, you use a conjugate in order to do that. Okay, so we're going to use the conjugate to get another term, and you'll see how it works. Okay, so if we multiply by the conjugate, We'll get in the numerator, well, simply using the difference of two squares, once again, to quickly multiply this product. In the numerator, we get 1 minus sine squared x. Okay, if you haven't used difference of two squares to quickly multiply, it's very, very effective in that sense, and it's also effective for simplifying terms. Okay, good stuff. Okay, and now we know that the numerator, using equation 1 again, is equal to cos squared x, and we could take out a factor of cos squared x. Causes cancel in the numerator and denominator, giving us a final answer of cos x over 1 plus sine x. Okay, so this is an example of using conjugates, okay, in order to prove identities. All right, so be familiar with that and don't be afraid to try it out, especially when you see terms like 1 plus sine x, 1 minus cos x, 1 minus sine x, you know, those type of terms. Okay, all right, so the last one of the day. All right, let's have a go. I saw someone asking, can you cross multiply? I don't believe you can cross multiply. We're trying to prove from left to right. Okay, okay, the next question, without using a calculator, I'd like you to find the exact value of sine of theta, given that cos of theta is equal to -3/5 and that theta is obtuse. So this is the last one of the day. Let's see what we get. And guys, strictly don't use a calculator. I warn you that if you do use a calculator, you might get it right sometimes, but not all the time. And we'll talk about that in probably another tutorial. So it's dangerous to use your calculator, especially when they tell you to find the exact value, okay? That suggests that they're looking for the answer in either surd form or rational form, okay? Don't apologize, David. It's always good to ask questions, give it a go. And, you know, as long as you're not getting it wrong in the exam, that's all that matters. We're all here to learn. So who's got this? Using exact values, how are we able to get sine of theta, given that cos of theta is equal to -3/5? Give you guys about a few more seconds. Natalie, 4/5. Again, first one in. Ella, followed by Ella again, 4/5. Angel says 4/5 maybe. Confidence, confidence. Be confident in yourself, okay? Ben Clay, 4/5 as well. Okay. Pook, 4/5. Anyone else? All right, sine of theta equals 4/5, and we're getting a ceremonious number here of 4/5. Okay, let us see how to do this. Okay, so knowing that we've been given cos theta is equal to -3/5, okay, we can use this identity to find what sine theta is, okay? All right, so using this identity, we can get that sine squared theta is equivalent to 1 minus cos squared theta. Taking the square root of both sides, we get plus or minus the square root of 1 minus cos squared theta. Okay, now I can't stress the importance of using a positive or negative sign. Alonzo, if you're out there, every time we're doing work, you must use a positive or negative sign when you are taking the square root of a term and then evaluate to see whether it's positive or negative. All right, so by plugging in -3/5 in place of cos theta, we get, and I'm just going to quickly go through this because we're running out of time, we're going to get that sine theta is equivalent to plus or minus the square root of 16/25. Okay, so going on and evaluating the square root term, we get sine of theta is equivalent to plus or minus 4/5. Okay, now you're not done here, okay, because we have been restricted by a few things here. We've been restricted by the fact that cos of theta is a negative number. It's negative 3/5. And also, our angle we're dealing with is obtuse, okay? So that tells us it's going to lie in a particular quadrant, okay? Now, the way I like to do this, and there is another method by using graphical methods, I like to use a cast diagram to tell me whether my angle is going to be positive or negative, okay? So this is the cast diagram where C stands for cos, A stands for all, okay? So A is where all of our trig functions are positive, S is where sine is positive, and the third quadrant is where tan is positive. Okay, so one of the key things we know is that cos is negative, okay? So what does that mean? As cos is negative, it means that it lies in either the second quadrant or the third quadrant. Now, why is that? It's because cos is only positive in the fourth or the first quadrant, okay? So it's always useful to write it out like this. And the second property we're given is that the angle we're looking at is obtuse, okay? What does obtuse mean? It means that the angle is between 90 and 180, okay? So that means when we're actually evaluating our angle, using these blue lines as reference lines, okay, and drawing the angle from the first quadrant, you're always drawing your angles from the first quadrant to the reference points. This angle here is clearly the one which is obtuse, as it's between 90 and 180, whereas if it was in the third quadrant, it would be a reflex angle, okay? So therefore, it tells us that we are lying in the second quadrant, all right? Sine of theta is in the second quadrant, therefore, sine of theta is positive, okay? And we get sine of theta is equal to 4/5, okay? So, you know, at this stage, it's very easy to just either just say this is the answer or just choose one and guess, but there's a bit of evaluation, there's a bit of analysis that needs to be taken in order to actually conclude whether we're positive or negative. All right, fantastic job, guys. I'm just going to jump back on. That's the last one of the day. All right, cool stuff. Thank you very much, guys, for joining. I hope that was useful for you. You know, with although this was AS level, which some of you might deem to be slightly, basic, hopefully you guys took some of the factors that are important. Some of the things that come up quite regularly are things like difference of two squares, working with algebraic fractions, taking the conjugates. These are things you need to have in mind, okay? Hopefully that was useful for you guys. Thank you very much for joining me. I believe we'll have Stuart back on tomorrow. So make sure you guys jump on. And yeah, if you guys have any questions or comments, just leave them down below. And if you appreciated the session today, just drop us a like. Be very, very grateful for that. Okay, good stuff. I'll see you guys tomorrow, and take care, guys. All the best.